learning the last method that we're going to use to solve a quadratic equation. That method is called the quadratic formula. It's just a formula that allows you to plug in A, B, and C to get the answers, to get what x equals to make the equation equal to 0. So this is the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I will burn that into your brain by the end of the chapter, so make sure that you just remember it and memorize it now. So now I thought that it would be fun if we completed the square to prove this formula, show you where this formula came from. So I would suggest that you write this down and pay attention because I am planning on making this an extra credit question on your next test. So here, in order to show this, we're going to start with just a basic quadratic equation. Ax squared plus bx plus c. And now we're going to just try to solve this equation for x by completing the square. The first step in completing the square is to get the constant term to the other side. So we're going to subtract c from both sides. Then I'm going to get ax squared plus bx equals negative c. I'm going to leave that space for the term I'm going to add in. Now I'm going to divide by a so that my quadratic coefficient is just 1. Remember, I have to divide everything by a. So my new equation is x squared plus b over ax equals negative c over a. Now I want to figure out the term that I need to add up to both sides in order to make the completing the square work. That term is always half of this term squared. Half of b over a would just be b over 2a. It's half because I'm now dividing by 2. And then I'm going to square that term, and that's going to give me b squared over 4a squared. So that's the thing that I'm going to add on to both sides. The next step is to rewrite this as a perfect square trinomial. In order to rewrite that, it's always just going to be x and whatever half of that middle term was. So x plus b over 2a squared. Now, it's probably a good idea to simplify this side up so that it's a more easy calculation. If I'm going to add these two things together, I need a common denominator, which means that my common denominator is going to be 4a squared. So I'm going to multiply this by 4a over 4a. So now that makes this negative 4ac over 4a squared plus b squared over 4a squared. Now that I have a common denominator, I'm able to add these two terms together. It doesn't really matter what order you put it in. I'm going to put this term first just because that's the way it looks like in the formula. So this ends up being b squared minus 4ac all over 4a squared. We're almost there. I know that this is a little complicated. Just bear with me. We're almost done. It'll make sense soon. So now we're just trying to solve for the x. So let's take the square root of both sides like we always do with completing the square. Now I'm left with x plus b over 2a on this side and plus or minus the square root of b squared minus 4ac all over 4a squared. Now, if you remember, we're not allowed to have a square root in the denominator. There's really a square root in this denominator here. So let's simplify by taking the square root of that bottom. So the square root of the bottom is just 2a. And I'm left with just the square root in the numerator now. B squared minus 4ac. So it's taking shape. It's really starting to look like that formula that we're trying to create. So now let's subtract this from both sides. And I get x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Conveniently enough, these two fractions have a common denominator already, so we're just going to add them together and get that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I know that that might have been a lot to take in. If you need to rewatch this video to make sure that you get that proof was, please do so at home. It will be extra credit on your next test. So that's the quadratic formula. So before we go on to an example problem, let me just do our little joke of the day. Our joke of the day is, it's pretty corny, sorry in advance. What kind of vegetable needs a plumber? And it's a leek. A leek is a kind of onion if you weren't sure what a leek was. Okay, so now here's our first example. So we're trying to solve this equation for x. So in order to solve this equation for x, I need to use a quadratic equation. In order to do that, let's just identify the a, the b, and the c, which we've had practice from in the beginning of this chapter. Here the a is 2, the b is 3. Here we're just talking about the numbers in front of the x squared, the x, and the constant term. Here that's negative 5. So now all you have to do is very simple, just plug it into the formula. So my formula says that x equals negative b, which is negative 3, plus or minus square root of b squared minus 4 times a times c, all over 2a. So now it's just a matter of simplifying things and working them out. So here I have, sorry, I just realized that I put ab instead of ac. So this shouldn't be a 3, this should be a negative 5. Sorry, that's not writing. So now this is x equals negative 3 plus or minus, this is just 9. Here, inside of here I have 9 minus a negative 40, plus 40. So I have negative 3 plus or minus the square root of 49 over 2 times a, which is 4. A is 2 over here. So now you have to actually do the square root of 49. So that's, we're lucky enough that that one came out nice and pretty, and it's just myself some more room. So this is negative 3 plus or minus 7 over 4. Now, if you can do that process, go ahead and do it. Negative 3 plus 7 is 4, divided by 4 is 1. And then negative 3 minus 7 is negative 10, divided by 4 is negative 10 fourths, which reduces to negative 5 over 2. So that's the problem. If you wanted to you could get the same answer by factoring this if you wanted, but this is the method for quadratic formula. So now let's try another example. So here, the first thing that you want to do is identify your a, b, and c. So my a here is the number, it's always the number in front of the x squared. Here there's no number in front of the x squared, so we just assume it's a 1. Here my b is 0.5, and my c, there's no constant added on, so c is just 0. So now it's just an easy one. It's just going to be x equals negative b, which is negative 0.5, plus or minus the square root of b squared, 0.5 squared, minus 4 times a, which is 1, times c, which is 0, all over 2a. A is 1, so it's just all over 2. So now this square root actually simplifies very nicely because there's a 0 in it. So I'm just taking 0.5 squared minus 0. So all this really is negative 0.5 plus or minus the square root of 0.5 squared. Well, hopefully you remember that the square root of anything squared is just that thing again. So this is really just 0.5 over 2. So now you just have to go ahead and do that. Negative 0.5 plus 0.5 is 0 over 2, still 0. Now let's do the other one. Negative 0.5 minus 0.5. That would be negative 1 divided by 2, which is negative 1/2. So sometimes when you have a quadratic equation that you're trying to solve, not everything is set equal to 0. Before you try to do the quadratic equation, you have to set it equal to 0. The reason for that is because the proof that we used had the equation set equal to 0, so we have to be consistent. So it doesn't matter which side you bring it to. When you're factoring, you want the a to be positive, but it doesn't really matter for the quadratic formula. So here I'm just going to subtract 3x and add 2 to both sides. So I get negative 4x squared minus 3x plus 2. It doesn't matter if you bring it to the other side, it's the same thing. Your answer will be the same. So now I'm going to go ahead and apply the quadratic formula. So I get x equals negative b. I guess I should have said it. So here a is negative 4, b is negative 3, and c is 2. So negative b is just positive 3, plus or minus the square root of b squared. Negative 3 squared is 9 minus 4 times A times C. So 4 times negative 8 is just negative 32. I'm going to put there. All over 2 times A. My A here is negative 4. So now let's try to simplify this. I have x equals 3 plus or minus the square root of 41 over negative 8. So if this square root of 41 could be simplified, then at this time we should simplify it, but the 41 is a prime number and it can't be simplified. So this is your answer. Realize that there's really two answers in there. There's 3 plus the square root of 41 over negative 8, and then 3 minus the square root of 41 over negative 8. So we're going to skip this example. So now let's talk about how to find the zeros of a function. So finding the zeros of the function is really the same exact thing that we've just been doing. All it means is find where this function equals 0. So here I have 0 equals x squared plus 5x minus 9. So once again, you're just identifying the A, the B, and the C. So my A is 1, my B is 5, and my C is negative 9. So here, I'm just doing x equals negative B, which is negative 5, plus or minus the square root of B squared, which is 25, minus 4 times A times C, all over 2A. A is just 1 here. So now let's go ahead and simplify this. So I get negative 5 plus or minus. Here under this radical I have positive 36. 36 plus 25 is 61, all over 2. So you should see if this square root simplifies here. Because this square root doesn't simplify, you kind of just have to leave it the way it is. Leave it at the square root of 61. That's your answer. And that's it. So don't forget to answer the questions and do your worksheet. Oh, the student of the day. Today the student of the day is Russell. Congrats, Russell. You're a student of the day.